Hi everybody, I hope you're all doing well. Today we're going to do a lesson on compound probability. So the probability that one or more event will occur. So here we go. Let me just set my marker. Okay, I think that'll probably be good. So it says dependent events are ones in which the outcome of one event affects the outcome of another event. So they depend on each other. Independent events, the outcome of one event does not affect the outcome of another event. So what is the probability that both A and event B happen at the same time? That would be the probability of A and B would be the probability of A times the probability that event B happened. So that's the formula we're going to use. You can always think of and probability as multiplication. All right, so I'm going to go to the next page here. Try not to mess up my video. So it says decide. Decide if the events are dependent or independent. Then find each probability. So it says the box contains 4 red, 10 blue, and 6 green marbles. Find each probability. So you select a red, then a blue with replacement. With replacement means that you are putting that red marble back before selecting the blue. So the probability of getting red, then blue, would be the probability of getting the first one being red times the probability of getting blue the next time. Well, what are the chances I'll get red on my first? That would be 4 out of 20 chances. Then we put that red marble back in and we draw a blue. So that would be 10 out of 20. So I like to kind of reduce my fractions before I multiply through. So this is going to become 1/5 times 1/2 would be a 1 in 10 chance that I would get a red on my first draw and a blue marble on my second draw. So now it says you select 2 blue marbles without replacement. So without replacement means the events are dependent on each other because you're not putting that first blue marble back. So probability of getting blue and then blue again. So probability of getting the first blue times the probability of getting that second blue. So probability of getting the first blue is like how it was before, 10 out of 20, and you might want to reduce, but just hang in there because I want to show you this. So now if we keep that first blue marble out, what are the chances I would draw a second blue marble? Well, I only have 19 marbles now, so my total is 19, and I only have 9 blue marbles in my box. So it's 9 out of 19. Because remember, I didn't put that first blue marble back in. So now we're going to end up with what? 1/2 times 9/19 would be 9 over 38. So we have a 9 and 38 chance of getting blue then blue, given that we didn't put that first blue marble back. So again, these are dependent events. Okay, let's move on to the next page. Decide if the events are dependent or independent, then find each probability. So example 2 says the probability of drawing a king and then an ace with replacement. So are these events dependent or independent? If you guessed independent, you would be correct because you are putting that first draw back. So let's first make sure we know a little bit about cards. In a standard deck of cards, we have 52 cards. All right, and we have 4 suits. Ace. Oh, not ace. We have hearts, diamonds, clubs, and spades. All right, so this is probability of finding a king and then ace with replacement. So the probability of getting a king and an ace. So that would be the probability of getting our king times, for and, the probability of getting our ace. So what's the chances we're going to get our king? Well, there's 4 kings in my deck of 52, so 4 out of 52. Then we are replacing that king, so we are putting that king back, so we still have 52 cards. So again, these are independent events. Okay, so how many aces do we have? We have 4 aces. So basically I have 1 out of 13 times 1 out of 13, which would be giving me 1 out of a 169. So I have a 1 in 169 chance of getting a king on my first draw and an ace on my second draw. Okay, so let's talk about the probability of drawing a king and then an ace without replacement. So without replacement would mean we have dependent events. So now that ace's probability is going to depend on the fact that we didn't put that king back. So again, the same formula applies. So the probability of getting a king and an ace, it is the probability of getting our king times the probability of getting our ace. So the probability of getting our king is the same as it was before, 4 out of 52. But now the probability of getting our ace depends on that. So now we only have 51 cards because we are not replacing that king. But we still have 4 aces in our deck. So we're going to get 1 out of 13 times 4 out of 51. It's going to give us 4 out of 663. So we would have that chance of getting a king and then an ace. So just to compare for you guys, 169th is like a 0.59% chance of getting a king and then an ace. And then over here, we have basically a 0.60% chance. It's a little bit higher, which makes sense because your ace, you have more of a chance of getting your ace because you have 1 less card in the deck for your second draw. So hopefully this idea of independent versus dependent events is kind of starting to sink in a little bit here. All right, so let's move on. Feel free to pause at any point. Okay, so now we're going to talk about this idea of being mutually exclusive. Mutually exclusive are events that cannot happen at the same time. So if you think about your Venn diagram, that means that there's no overlap whatsoever. So are these events mutually exclusive? Explain. So again, I'm just going to kind of highlight it cannot happen at the same time. So rolling an even and rolling a number greater than 5 on a dice. Are those mutually exclusive? Can they happen at the same time? So let's look here. Our evens would be our 2, 4, 6, and a number greater than 5 would be rolling a 6. So we can see that you can be even and be greater than 5 at the same time. So these events would be not mutually exclusive. Example, the number 6 is in both of those sets. How about rolling an even and rolling a number less than 2 on a dice? Well, rolling an even, I switch up my color here, we'll do blue, would be a 2, 4, or 6, and rolling a number less than 2 would be just getting a 1 on the dice. So as we can see, these 2 events cannot happen at the same time. If I roll it even, I am definitely not rolling a number that is less than 2. So these events would be yes, they are mutually exclusive. If you're wondering what that tapping is, it is me using my Apple Pencil on the screen. I'm going to consider abandoning that, but my handwriting may get worse. So, well, let's move on. Maybe on the last slide or after that, I don't know. I'll adjust if I need to. If the tapping's bothering you, let me know. Okay, so we talked about the fact of being mutually exclusive are events that can now happen at the same time. So it says if A and B are mutually exclusive, then the probability of A and B happening at the same time would be 0. Oops, gotta put my pen on. So there is no probability, there's no overlap in these circles. So in which case, the probability that event A or B occurs is the probability that event A happens plus the probability that event B happens. So as you can see, when we're doing OR probability, OR is addition. When we did AND probability, AND was multiplication. So what happens if A and B are not mutually exclusive? So there is this little bit of overlap where something could be counted twice. Well, then my formula for the probability of A or event B happening would be the probability that event A happens plus the probability that event B happens minus the probability that A and B happen at the same time. So basically, if we count a number in here in event A and count the same number in event B, we counted that number twice or that event twice, so we need to subtract out the duplicate. We'll illustrate that better on our next example. So let's look at this. So example 5, a standard number cubed is tossed. Find each probability. So the probability of being odd or prime, remember, or probability is addition. Okay, so I feel like this is getting a little bit thick here. All right, so this would be the probability of being odd plus the probability of being prime minus the probability of being odd and prime. So let's kind of talk about what we got going on here. So our odds would be our 1, a 3, or a 5. Being prime, what are our primes? Well, technically 1 is not prime because the definition of being prime is being divisible by 1 in itself. And since 1 is itself, the first prime number is 2. So my primes would be 2, 3, and 5. So as we can see, these events are not mutually exclusive. They can happen at the same time. You can be odd and be prime. Oh, not just 5, but also 3. So what we see is that there are two numbers, 3 and 5, that counted double in this calculation. So the probability of being odd, we have 3 numbers out of 6, plus the probability of being prime is also there's 3 outcomes out of 6. So we can't just say that as 6 out of 6 because we counted the 3 and the 5 twice, once for being odd and once for being prime. So my odd and my prime are my 3 and my 5. So we are going to subtract out a 2 out of 6. So that leaves us what? 6 minus 2. That's going to give you 4 out of 6, or a 2/3 chance of getting an odd or a prime. So hopefully this kind of makes sense that we have to subtract out the fact that we counted 3 and 5 in the probability of being prime in that 3, and then also in the probability of being odd. So we counted the 3 and the 5 twice, so we had to kind of undo and subtract the duplicates. So let's talk about the probability being even, or less than 4. So our evens, we have our 2. What's going on here? We got okay. So even would be a 2, a 4, a 6. Less than 4 would be a 1, a 2, or a 3. Are these events mutually exclusive? And I hope you would say no, because they can happen at the same time. We can see here that the 2 is going to happen at the same time. So we have the probability of being even plus the probability of being less than 4 minus the probability that you are even and less than 4. Okay, so probability of being even is we have 3 numbers out of 6, plus probability of being less than 4, we also have 3 numbers out of 6, minus the probability of being even or less than 4, which is the number 2, so that would be 1 out of 6. We counted that 2 twice. So this would actually be a probability of 5 out of 6. Okay, so yeah. Anyway, that's kind of the idea behind the odd probability. You have to look and see if the events are mutually exclusive. All right, moving along. Example 6, we're almost there. This is about 53% of college students are under 25 years old. About 21% of U.S. college students are over 34 years old. What is the probability that a U.S. college student chosen at random is under 25 or over 34? So we're doing or probability again. Oops. Great. I'm going to have a lot of oopsies on my end here because I'm not going to redo the video. Or, okay, so probability of being less than 25 or greater than 34. So are these events mutually exclusive? What do you think? I hope you would say yes. And why is that? Because you will not have a person who is less than 25 and also be greater than 34. It's not possible to be both at the same time. So these are mutually exclusive events. Hey, when I write in cursive, it doesn't make as much noise. All right, so this would be the probability of being less than 25, and again, or is addition, so plus the probability of being greater than 34. And there's nothing to subtract because there's no one who is in both groups at the same time. So what are the chances of being less than 25? Well, they tell you here that 53%, so that would be 0.53. We can just do our probability percent as decimals, plus the probability of being greater than 34, those people who maybe are going back to school, would be 21% or 0.21. So together, we're going to have what, 0.74. So you have a 74% chance. So this is the same as the 74% chance of picking somebody who is under 25 years old or over 34 years old. So again, this would be an example of mutually exclusive. Again, nothing to subtract, but again, or is addition and is multiplication. So that's the key point I want you guys to remember. Okay, and my last slide. Oh, it's kind of boring doing this without you guys. All right, it says A and B are not mutually exclusive, which means that they can happen at the same time. Find each missing probability. So we are going to use the formula for compound probability for or. So probability of A or B. When we're not mutually exclusive, we have to take the probability of event A happening, add it to the probability that event B happens, and subtract the probability that A and B happen at the same time. So, and again, we will have that part because it says that the events are not mutually exclusive. So we will have those parts that were counted twice. So we'll just call this, the first one, we'll call it number 1. Okay, so number 1. So if we want to find the probability of A or B, let's write that out. Probability of A or B, they kind of give us our information. So the probability that event A happens, they're telling us, is 1/4, plus the probability that event B happens is also 1/4. fourth, and minus the probability that A and B happen at the same time would be 1/8. So just to remind you, you cannot subtract or add fractions unless you have a common denominator, which in this case is going to be 8. So, we'll just make these denominators 8. And I know you guys don't need to see this, but so we'll have what? 2/8 plus another 2/8 minus 1/8. So we have 4/8 minus 1/8 will leave us with a 3/8 chance of event A or B happening. Okay, so I'll pick another color here. What color do we want? Well, let's do this pretty blue over here. All right, that sounds good. Okay, so for number 2, this time they're giving us the probability of A or B happening is 5/6. So it's going to be 5/6 equals the probability that event A happens is 2/3 plus the probability that event B happens is 1/2 minus the probability that A and B happens. Let's just call it, for now, let's just call it X. So again, common denominator would be a good idea here. So we'll have so we're going to end up with 5/6 equals 4/6 plus 3/6 minus X. Take it up here. So 5/6 equals 7/6 minus X. So if we subtract 7/6 to both sides, we're going to get negative 2/6 equals negative X. So X would be a positive 2/6 or 1/3. So you actually have a 1 in 3 chance of event A and B happening at the same time. So that's it on compound probability. Next lesson we'll be talking about conditional probability. So I guess work through the problem sets on these, and if you have any questions, I will put a discussion board in the folder where you found this video, and you can put questions out there. I'm okay with you guys taking pictures of certain problems and posting them to help each other out, or FaceTiming, or whatever you guys do. I know it's a different world out there and nothing that we've ever experienced. So you need to do what you need to do to help each other understand the material. I'm available. We will get through this together. Okay, well, signing off. I'll see you guys, or I won't see you. Hopefully I'll see you this year. All right, I'll talk to you later. Bye.